Question number 2 says, researchers at the Centers for Disease Control and Prevention have been studying the decay pattern of a new virus with a decay rate of 40% per hour. They start with 500 viruses. How many viruses will they find after 10 hours? And they want us to round to the nearest whole. So I like to define all my variables and organize all the information that I know. So I'm looking for the value of the population, and I know I start out with 500. My K is going to be 0.40, and it's actually going to be a negative 0.40 because it says decay. So this is negative 0.40. And then my T is equal to 10 because they're asking how many viruses will they find after 10 hours. So just as a note, this K was negative because they said decay. Okay, so I need to plug this information into my formula. So 500 times e raised to the negative 0.40 times 10. And I get 9.157, so I want to round this to the nearest whole number. So this will be 9. So 9 viruses. Now, these types of problems are actually very similar to the continuous compound interest problems in the previous section. And the reason for that is because mathematically the continuous compound interest formula is equivalent to our exponential growth and decay formula. So that's just kind of an interesting fact.